Hello, welcome to the 2-5 notes on proving lines are parallel. So the first thing we have to talk about are converse statements. So below here in the blue and purple, we have two statements that are written in if-then form. They are considered converses of each other. So we're going to compare them and then see if both statements are true. So the first one says, if two angles are right angles, then the angles are congruent. Well, we should all know that right angles means they have a measure of 90 degrees. If something is a right angle, its measure is 90 degrees. And if two of them are right angles and they both measure 90 degrees, then of course they're congruent, because congruency means they have the same measure. So the first statement here is true. The second statement in purple says, if two angles are congruent, then the angles are right angles. Well, if two angles are congruent, that doesn't mean they have to be right angles. They could both be 20 degrees. They could both be 17.62 degrees. We just don't know, so this statement is false. Okay, so I want to know, can you write a statement and its converse, which are both going to be true? So to summarize, a statement and its converse means you switch what happens, or the statement that comes after the if and after the then. So for example, if you are in geometry, then you are a freshman. The converse would be, if you are a freshman, then you are in geometry. Both of my statements are actually false. If you are a freshman, then you are in geometry. Not true. You could be in algebra, you could be in algebra 2. There's lots of classes you could be in. The second statement I said is, if you are in geometry, then you are a freshman. I have plenty of sophomores in my other geometry classes, so that is also false. So I would like everybody here to try to think of a statement and its converse, which are both going to be true. These are sometimes pretty difficult to come up with. For example, if it is raining, then the sidewalk is wet. The converse of that would be, if the sidewalk is wet, then it is raining. The first one was true. If it's raining, the sidewalk's going to be wet. The second one, if the sidewalk's wet, doesn't mean it's raining. It can mean rain before. It can mean that somebody has their sprinkler on. It can mean there was a water balloon fight. There's lots of different reasons for that to happen. So these are kind of difficult sometimes to come up with. I always find mathematical definitions are the easiest. So for example, mine here, I wrote, if two segments are perpendicular, then they form four 90-degree angles. And the converse would be, if two segments form four 90-degree angles, then they are perpendicular. So notice that what I've done is I've switched what came after the if is now after the then, and then what came after the then in my original statement now comes after the if. So they just flip-flop where they are. All right, next definition here is a biconditional statement. Biconditional statements mean if an if-then statement and its converse, if they're both true, that's called biconditional. There's going to be a symbol that is used for that if you were to use symbolism, and you may see this in some upper level math classes, but it's kind of a double arrowhead. Points both ways, and then there's two horizontal lines. So in this section, we will see that postulate and theorems about angle pairs formed by parallel lines have converse statements that are also true. So all of those things that we learned about if lines were parallel and cut by a transversal, all those angle relationships that occurred, now the converses will also be true. All right, so the first one we're going to talk about here is the converse to the corresponding angles postulate. This says, if two lines are cut by a transversal, so we have two lines, we don't know if they're parallel, if they're not, I'm cutting them with a transversal, and I'm then telling you that corresponding angles are congruent. So this angle, for example, is congruent to this one. And if I had these two lines here, let's call it A and B, if I know that those angles are congruent, corresponding angles congruent implies the lines here, A is parallel to B, versus what we did before. I told you the lines were parallel. So A is parallel to B, and then I cut this, I would say, what do you know about angle 1 and 2? You would say angle 1 is congruent to angle 2 because we know that the lines are parallel. So it's just a matter of what you were given, what information you're given first. For example, if I told you, okay, I have two different pets at home. One's a cat and one's a dog. So we're gonna decide what is true about the sounds they make. And I show you a picture of my dog and I say, well, what sound does it make? You would say, it barks. If I instead played for you the sound my dog makes or my pet makes and it was a barking sound, then I'd say What do you know? What pet is this? A dog. So the difference here is in this one, if I named this angle 1 and 2, if I said angle 1 is congruent to angle 2, I would say, okay, corresponding angles are congruent. That implies, that's what this little arrow is, parallel lines. So this is the converse. This one goes here. You don't know anything about the lines to start with, versus the postulate said the lines were parallel. I told you A is parallel to B, so you would say parallel lines implies corresponding angles congruent. Just think about what you are given. Are you given information about the lines? Therefore, you know stuff about the angles? Or are you given information about the angles? Therefore, you could imply things about the lines. That's the little caveat here that you have to keep separate in your mind. So there are 4 other ways to prove that the lines are parallel. So the first one's alternate exterior angles. The second one's consecutive interior angles. Alternate interiors, the third, and then perpendicular transversal converse. So again, in these pictures, for the first one, if I know that angle 1 is congruent to angle 3, then I know the lines are parallel. In the second one, if I know the consecutive interior angles add up to 180, that they're supplementary, then I know that the lines are parallel. For the third one, if alternate interior angles are congruent, 6 and 8 in this question, or in this picture, then P is parallel to Q. And then finally, if we have 2 lines that are perpendicular to the same line, both P and Q are perpendicular to the same line, then I know that the lines have to be parallel. There's no way that if they're not parallel, there's no way that they would both be perpendicular to that transversal. All right, parallel postulate. And we use this one with the crooked line problems when we drew in that auxiliary line. And it says, if given a line and then some point that's not on the line. So here we had line M and then a point not on line M. How many ways can I draw a line? How many different kinds of lines can I draw that are going to go through point P and at the same time be parallel to M? Only one. There's only one line. No matter how many people I would call up here and be like, draw a line parallel to M, but it has to go through P, everybody would draw the exact same line because there's only one. So let's take a look at our first example. We are given the following information. State whether it would be possible to prove any of the lines are parallel. If so, state the postulate or theorem that justifies your answer. All right, so angle 1 and angle 2. So what we are looking for is, are these corresponding angles? If they're congruent, that means the lines are parallel. Are these alternate interior angles or alternate exterior angles? If those are congruent, then the lines are parallel. And then if they're consecutive interiors that are supplementary, then the lines are parallel. The last one is, if they're both perpendicular to a transversal, then they have to be parallel. So angle 1 and angle 2, hopefully you're like, those aren't even in separate clusters. They're the same ones. These are vertical angles. The answer here would be no. This doesn't prove anything being parallel. I could have any sorts of lines. Vertical angles are still going to be congruent. Okay, let me try to erase this. Now, next one. 3 congruent to 5. If I mark those angles, let's go ahead and mark those, 3 and 5. All right, so now we're in business. We have 2 separate clusters of angles that we're looking at. We're looking over here and here. 3 and 5. Are they any of the 4 that are created with a transversal? Yes, they're corresponding angles. So what I would write here is yes. And the reason is corresponding angles congruent implies parallel lines. Now, which lines would be parallel here? M parallel to N. Because P would be the transversal, M and N are our lines that would have to be parallel. I erased everything that I drew there. And part C, angle 2 and angle 3. If these 2 angles are congruent, 2 and 3. All right, so now we are looking at these 2 clusters. So the answer would be yes. If 2 is congruent to 3, those are alternate exterior angles. If these alternate exterior angles are congruent, that implies parallel lines. And which lines would be parallel here? L parallel to M. Okay, so here we're given information about the angles. That implies information about the lines versus what we did a few sections ago, which was I told you the lines are parallel, therefore you knew stuff about the angles. And I know it's kind of confusing, and I know sometimes kids think it's the same thing, but it's really the converse. Example 2, now we're going to throw in some algebra. It says, find the measure of angle ZYN so that line PQ is parallel to line MN and state the postulate theorem used. All right, so the first thing I want to look at is, we don't know if the lines are parallel, but the names of the angles still exist. Corresponding angles, alternate interior, etc., all of those still exist, even if the lines aren't parallel. Those names are still definitions that we learned in section 1 of this chapter. So if I want to make these lines parallel, these are alternate exterior angles. And if they're congruent, then I would know the lines are parallel. Or parallel lines, whichever way you want to write it. So I'm going to find the value that's going to make them equal to each other. 11x minus 25 equals 7x plus 35. If the lines are to be parallel, then those two angles have to be congruent. All right, I'm going to subtract 7x from both sides. I get 4x minus 25 equals 35. Add 25 to both sides. I'm going to get 4x equals 60. Divide both sides by 4. We get x equal to 15. All right, so a lot of times in geometry, we find x, but that's not the end-all be-all. We have to go back and find what we wanted, what we were asked to find. We were asked to find the measure of angle ZYN. So ZYN is this angle right here. So it's 7x, x is 15, plus 35. So what I get as an answer is 105 plus 35. That gives me 140 degrees. And that is my final answer. If I wanted to check, I should plug it in here for this angle because I should get 140 as well. All right, let's look at example number 3 over here. We are finding x so that A is parallel to B. So here's line A, here's line B. We want these to be parallel. If they're to be parallel, if alternate interior angles, which is what this is, if they're congruent, that implies parallel lines. So therefore, I'm going to set those equal to each other and solve for x. 7x minus 21. All right, pause the video, go ahead and find x, and then find the angle that we are asking you to find, LRP. All right, so you should have gotten that x is 14 and the measure of angle LRP is 103. Now, what I highlighted here, when you have to write the theorem or postulate, if that's in your classwork or if that's on an assessment, a quiz or test that we take, this is what we expect to see, the entire thing, not just AIA. We have to know the difference between alternate interior angles imply the lines are parallel versus the converse, which would be given that the lines are parallel, we know the angles are congruent. One more thing I'll say is if you found the measure where x is, this angle is 77 degrees, but they wanted LRP. So you have two choices. You could find the one adjacent to it that it's 77 and they're a linear pair, or if you plugged in here and got 77, those are consecutive interiors, so they would be supplementary if the lines are parallel. All right, example number 4. Find x so that A is parallel to B. Okay, same old story, different problem. State the theorem or postulate. So alternate interior angles congruent, because that's what these two angles are. They're alternate interiors, this one and this one. If they're congruent, then the lines would be parallel. So visually, just looking at this problem, hopefully you're saying, oh, okay, this is going to be a quadratic. How do I know? As soon as I looked at this, the first thing I noticed is, okay, we have an x squared. As soon as I see an x squared, that's a quadratic equation. It's no longer linear because my highest power of x is 2. So let's set this up. X squared plus 36 is going to equal 6x plus 27. I am going to bring everything from the right side to the left side because it's a quadratic and I have to get it equal to 0. So I subtract 6x, I subtract 27 from the left and right. Okay, I'm going to write my left side in standard form. I have x squared. The only x's I have is this minus 6x. I have 36 minus 27, that is plus 9, going to equal 0. To factor this, we are looking for two numbers that multiply to be 9, and at the same time, they have to add up to be negative 6. So my factors of 9 are 1 and 9, 3 and 3. Now, because they have to multiply to be a positive, and at the same time add up to a negative, the only way you're going to get two factors that multiply to be positive are if they're both positive or if they're both negative. Because my sum here is negative, I know they both have to be negative. -1 plus -9 does not equal -6. -3 plus -3, ding, 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 that's the winner. So because my coefficient, my a value in front of x, my coefficient of x squared, I mean, is a 1, I don't have to break up the middle term. I just throw these in. It's guessing and checking. Remember, this is foiling in reverse. So I get x is equal to 3, but I'm only going to write that x is equal to 3 one time, because if I wrote it twice, it's redundant. There's no reason to say x is 3 or 3. I just write 3. All right, so now let's see what we were supposed to find. We have to find the measure of each angle, so let's go ahead and do that. We're going to do 3 squared plus 36. That's 9 plus 36. That's 45 degrees. For this one, if I plug in 3 here, 6 times 3 plus 27. 6 times 3 is 18 plus 27 gives me 45 degrees. If I got two different answers, I know something is off. I messed up somehow. So here, it's 45 degrees, both of them. All right, so that's it for this set of notes on 2-5. Next time you will work on 2-5 classwork. Thank you so much for watching. Have a good one. Bye.